In this session, we're going to look at how to use pointers to move data around between functions in our code. So we've been looking at pointers and how they are associated with arrays. And if we do a quick review before we go on, it'll help to solidify some of these concepts before we start getting a little more daring with our pointer use. So let's take a look at what we have here. We have a character array this time, 10 characters. The array itself is called S. And then we've defined a pointer to a character. There really should be a space in there between the R and the star, but it will work. Actually, it could be on either side. It'll still work. So we can use that to point into our string. Then we assign that string pointer the first address of our array, either using the straight address to address assignment or by saying the address of the first element. So we know that we can, our standard way using array subscripts or array notation is to say S element n, and that would get us a given character. Or we could say the contents of our pointer plus the offset into the array. So both of those would get us the same value stored in CH at the end. Where pointers are going to be particularly useful to us is when we want to pass arguments into a function. So far, all the passing that we have done has been by value. And that means if this is our original data here, the yellow one, and we pass it to a function by value, we're actually giving them a copy or another version of that value. It's like a photocopy. So the original one is maintained, its value is maintained, and it's not going to change. It doesn't matter what we do in the function to this other one. So we can write all over this, we can change it 29 times. This one, if it had the value 10 before, it's still going to have the value 10 now. So, for example, if we had a call, do something, and we pass number like this, and it is expecting an integer, and inside that function it treats it as n. This one would be number, this one would be n. So we can do whatever we want over here. This one, number, is not going to change at all. If, on the other hand, we pass by address, which means we're using pointers, it means we're working with the one and only original. So our call would now look a little bit different. So now we're passing in the address of this. So we're telling it where this one is in memory. Here, it's expecting a pointer. So it's expecting this pointer, and as long as it's pointing to an integer, it really doesn't care where it's pointing. If we do some arithmetic, so we say the contents of address is now been, we've got a mod operator here. We haven't seen that for a while. So a mod we're going to take what's in address, we're going to divide it by 2 and store the remainder in address. So this is now going to have that new result. And when we get back to wherever this call was, number is going to have that new value as well. So when we pass by value, the original contents are maintained. When we pass by address, those contents will change if something in the function caused it to be different. So let's quickly review passing by value. This is what we've been doing in the course so far. So we have a function called useNumber. Here's the prototype. Here's the function itself down here. We can see that it's expecting an integer, and inside this function, that integer is going to be called number. So here I've assigned number a value of 45, and I print out inside the function useNumber, number is equal to, and then I'm going to print that 45. So then if we come back to main, we can see we have a variable here called number as well. These are actually two different values, two different variables. This one is declared by main, and it exists, or its scope is while main is active. This number here is declared by being part of the parameter list. It's declared in useNumber, so its scope or life is only as long as useNumber is active. So we come up here, we have an integer called number with a value of 25. We print at the beginning number is equal to, It's going to print number, which is 25. Then we call our function useNumber. We're going to pass the 25 in. So it comes down to here, number gets 25, it immediately gets changed to 45, is printed out, and then we come back to where the function was called from, and we print after the call to useNumber, number is, and I've got an extra n there in my prompt, which we can see up there, and it's going to print out the current value of number. So let's see what actually happened. In our first print statement, it said at the beginning, number is 25. Then it goes into the function, changes number to 45, and prints inside the function useNumber, number equals 45. So we changed it in here, but we changed the copy. And that's the important thing to remember. It was the copy that was changed. Now we come back. The next instruction is after the call to useNumber, number is equal to, and there's our output. So after the call to useNumber, and there's my typo, and number is equal to 25. So why is it 25? Is because the changes that happened in the function did not affect the original value of number because we passed it right here. We passed it by value. Now let's look at almost the same program, but this time instead of passing by value, we're going to pass by address. So let's look at our prototype first, because now we can see over here we have a pointer. So we have a pointer called number pointer, which is pointing to an integer. If we come down and look at the function, there's our pointer, and here we say the contents of number pointer, so where we're pointing, is now going to be assigned the value 125, and we're going to print that out. So here we're printing the contents of number pointer. So that's, remember, that's where it's pointing, the value it's pointing to. Let's follow this through from the beginning. We have a variable called number declared in main. It's assigned the value 25. So we're going to print at the beginning number equals 25, which is what we see right here in our output. Now we go into the function, change number, and it passes in not number, but the address of number. Okay, so this is pretty important right here, that we've passed it by address, and that's how we know that we're passing by address and not by value. So that comes down here, so we have an address, so number somewhere has a block reserved in memory, and let's say it's at address X. So what we got here, our pointer now says, our pointer has that address of X. So when we say the contents of our pointer, we're saying the contents of this, which is 25. We're saying reassign that to be 125. Our print now says print that value out, so print the contents of where we're pointing, so it prints the 125. Then we finish the function, we come back to the next instruction, and it says print after the call to change number, number equals, and we print number again. But this time after the call, we can see that it's 125. So what happened? We passed by address here, we changed by accessing the address, we changed the contents here in the original location, and then when we come back up here, that changed value stays. Now so far, everything we've talked about with pointers has had to do with arrays, but we can also use pointers to work with regular primitive types of data, like integers, floats, characters, and we can also use it to look at aggregate data types like structures. So it's very common to pass structures in to functions and want there to be changes made in that structure. So let's take a look at our call here. So we've got something called change year, and we're passing in now, we should recognize that as the address of today. So today is a structure, and it has information about the day, So here we can see an example down here, the year, the day, and the month. So year is an integer, day is an integer, month is actually a string defining February. So what happens now, if we look at the function itself, so there's the function name and not returning anything, what's important is what's right here. So there's our data type, telling us we have a structure of type date, so somewhere there would be a template defined for that. And here we have a pointer. So we know we're getting the address of our structure passed in. And as soon as we know we have the address, that means if we make changes, those changes are going to be permanent. So we get into our function. And if you look at this line, you'll notice something new here. You will notice an arrow notation, and we haven't seen that yet. So whenever we are working with a structure and we want to access the fields via a pointer, we have to use that arrow notation. So it's a hyphen followed by a greater than symbol. So that accesses our field. So here we are saying in the year field, assign it 2007. In the day field, assign it 1. And remember, when we're assigning strings, we have to use one of the string functions. So we're going to copy the string February into the month field. Whenever we return from this function, so that was the last thing we did, when we return to the instruction after this, the contents of today's structure are going to have these new values in them. So we can pass structures in by address as well. So let's do a quick recap. If we pass by value, then it means our original is not changed. Any changes that the function would make is made to a copy. If we pass by address, we're telling it where that original is, and it says if you want to make changes here, those changes I'm going to live with afterwards. They're retained.